What if I told you that the universe is filled with particles so elusive and mysterious that they pass through everything, nearly undetected? Welcome to the fascinating world of leptons, the elementary particles that don't undergo strong interactions. Leptons come in two main classes: charged leptons, also known as electron-like leptons or muons, and neutral leptons, more commonly known as neutrinos. Charged leptons can mingle with other particles to create various composite particles, like atoms and positronium. On the other hand, neutrinos are the introverts of the particle world. They rarely interact with anything and are consequently rarely observed. The most well-known of all leptons is the electron. But the electron isn't alone. There are 6 types of leptons, known as flavors, grouped into 3 generations. The first generation leptons, also called electronic leptons, include the electron and the electron neutrino. The second generation, the muonic leptons, comprise the muon and the muon neutrino. The third generation, the tauonic leptons, include the tau and the tau neutrino. Among the charged leptons, electrons have the least mass. The heavier muons and taus rapidly change into electrons and neutrinos through a process of particle decay, transforming from a higher mass state to a lower mass state. As a result, electrons are stable and the most common charged lepton in the universe, whereas muons and taus can only be produced in high-energy collisions, like those involving cosmic rays and those carried out in particle accelerators. Leptons possess various intrinsic properties, such as electric charge, spin, and mass. Unlike their particle cousins, the quarks, leptons are not subject to the strong interaction. However, they do interact with gravitation, the weak interaction, and electromagnetism. The last of these interactions is proportional to charge and is thus zero for the electrically neutral neutrinos. For every lepton flavor, there's a corresponding type of antiparticle, known as an antilepton, that differs from the lepton only in that some of its properties have equal magnitude but opposite sign. Some theories even suggest that neutrinos may be their own antiparticle, although this is still under investigation. The first charged lepton, the electron, was theorized in the mid-19th century and discovered in 1897 by J.J. Thomson. The next lepton to be observed was the muon, discovered by Carl D. Anderson in 1936. Initially classified as a meson, it was later realized that the muon behaved more like an electron, only with higher mass. The concept of leptons as a family of particles was not established until 1947. In summary, leptons are elementary particles that come in 2 classes: charged leptons and neutral leptons. There are 6 types of leptons, grouped into 3 generations. Leptons have various intrinsic properties and interact with gravitation, the weak interaction, and electromagnetism. The study of leptons continues to provide valuable insights into the fundamental nature of the universe.